All right, discussion topics. Okay, so we'll start with concentric slave cylinders. So concentric slave cylinders is not really a new topic for us all. I had a look today and we're up to about 125 different types of concentric slave cylinders now in our range. And they've obviously become a lot more popular with vehicle manufacturers. Basically, any late model vehicles coming out of Europe or the US, even Japan and China now are adopting the technology. So I think we'll see the gradual phasing out of the conventional release bearing and release mechanism in preference to the concentric slave cylinder system. So to get started, hydromechanical rule number one, fluid transfer. So the amount of fluid displaced from the master cylinder should equal the amount of fluid displaced at the slave cylinder, whether it's a conventional slave cylinder or a conventional slave cylinder or a CSC, a concentric slave cylinder. That should be the equation. But if it's not, this is where obviously we can run into some issues with clutch disengagement type problems. So one of the first things that we'd be looking for when we experience a clutch non-release issue is an expanding flexible delivery line. It was interesting, one of the first experiences I had of this was when we sold a TYK 6878 ST Safari Tough Clutch kit into an early model Hilux, and the customer had taken out a standard clutch, and this thing was an LM106 and it had travelled a couple of 100,000 Ks. The guys at Lilydale Brakes would probably remember this pretty well. And the guy couldn't get it to release, and the clutch came back out, and we put it on our test bench, and we found, with the 8mm of diaphragm travel, the clutch was disengaging quite nicely, and we couldn't figure out what was going on. Go back, check the master cylinder and slave cylinder, nothing obvious going on there. And that particular Hilux had a flexible line running along the firewall, connecting the master to the slave. And although you couldn't see it by eye, that flexible hydraulic line was expanding under pressure. It had the greater release load required of the Safari clutch, and that line was expanding and causing a disengagement problem. So changed the line over, and it fixed the problem. So that's just a good one to keep in the memory banks, that if you come across a clutch disengagement problem, that's one of the first places we like to start with. A second fairly common one is the delamination of that flexible type line. So the internal material comes away internally, I guess, and it restricts the amount of fluid that can flow down to the slave cylinder, and that can cause you a disengagement type problem. So that's another fairly common one, but not typically obvious to everybody. With regard to concentric slave cylinders, why are vehicle manufacturers travelling in this way or looking to utilise more and more of these? It's a fairly simple explanation. When we're using a concentric slave cylinder, we're getting away from all the mechanical associated problems of a release fork, wear in a fork, wear in a pivot ball, problems with the cross shafts and these types of issues, where the concentric slave cylinder bolts to the front of the transmission and is relatively easy to install, and doesn't cause the same sort of problems that a conventional release mechanism does in time. And the CSC, of course, can be replaced. We suggest replaced each time the clutch kit is replaced. With regard to the operation of a concentric slave cylinder, so it's quite simple, but obviously when you put your foot on the clutch, the fluid's displaced down to the concentric slave cylinder, which forces the bearing out onto the diaphragm spring to obtain release. So typically in the installed position, the bearing operates about halfway down the bearing slide or tube, and as you depress the clutch, it moves out towards the transmission. Typically in a European application or a Japanese application, the bearing will only move 6 to 8 millimeters along that slide, or in American type applications a little more, maybe up to 12 millimeters. What we shouldn't ever see really is the release bearing extending along that slide and popping off the end of the slide, and that's typically occurs from an overstroking type issue, where there's fluid being displaced to the concentric slave cylinder and not being allowed to travel back to the master cylinder quickly enough. And we don't often see that, but we do see that from time to time. And we shouldn't also see the bearing bottoming out on the bottom of that guide tube or sleeve until the clutch is really fully worn out. If it's bottomed out prior to that, there's a problem with the geometry of the clutch. Some of the causes of concentric slave cylinder failure that we see, the number one is fluid contamination. I speak to the guys at the workshops often, and one of the things that kind of strikes me is nobody really flushes the hydraulic system as they should. They lock it off, change the cylinder over, and sometimes just bleed it up with old fluid, top it up with new fluid, and away they go. The manufacturer's recommendation is to change the fluid every 12 months on a concentric slave cylinder, typically .3 or .4 brake fluid, but always refer to the manufacturer's specification for this. But every time the concentric slave cylinder is replaced, the fluid should be flushed right through the system with new fluid. And you can see in the image there, the old fluid with debris in it gets stuck under the seal and causes the fluid to bypass that seal and the cylinder to start leaking. And one of the other causes of failure that we see also is incorrect fluid or contaminated fluid. The seals swell, and again, the fluid bypasses that internal seal and starts leaking all over the place. So I always recommend to flush the system entirely out with new fluid when fitting the new CSC. This is another interesting one that, talking to guys at workshop, when we show them, I think it's Tech Note 45 that we pack in our clutch kits, don't compress the CSC. People often say to me, I do that every time and I've never had a problem. Maybe more often than not, they might get away with it, but dislodging it in your hands can, compressing it in your hands can dislodge the internal seals. And also we make mention of the inner flange tube coming away from the body of the cylinder. That can also happen, particularly I think it is in Astras from memory. So that's just something to be aware of. Don't depress it in your hands before it's mounted to the front of the transmission. And these are just a few simple pointers, key points when installing the concentric slave cylinder. So always make sure the first motion shaft is cleaned, and that the front face of the transmission where we're bolting up our cylinder to. Make sure that any O-rings are replaced. So this is a good one to remember. We typically try and supply an O-ring if it's required. Not all CSCs require them, but in the majority, yes, they do. If we don't offer one, or we don't pack one in the kit with the cylinder, it doesn't always mean that it's not required. So rule of thumb, if an O-ring comes out of the vehicle, an O-ring needs to go back in there. We try and ensure that O-rings are always packed in our kits, but they're not. The particular one we require for the application is not always available to us. Another interesting one that we see from time to time is guys putting them up to the front of the transmission, grab the rattle gun, tighten them up very quickly, and the cylinder is not often its spigot located over the front face of the transmission, and it may not be sitting squarely, and they rattle them up and it cracks the base of the cylinder. And that's not always visible at the time that the CSC is installed. So that can be dangerous as well, because they'll start leaking once they start operating them. So we'd recommend normally 2 or 3 bolts, finger tight, make sure it's secured on the spigot location area before you really start tightening them up, and tighten them up to the manufacturer's recommendation. Also recommended to be bled by the manufacturer's advice, and I think we've got some more information about that a little further on. There we go. So slow and consistent depressions of the pedal should be applied. So this is particularly important in all cases, but particularly important, there is a Holden Astra, where the original cylinder was an FTE cast aluminium cylinder, and LUK offer a plastic cylinder to replace that. But when you do replace it, you need to remove a grommet from the hydraulic line. And installers are not always doing that. And if they replace the FTE cylinder with the LUK cylinder and they don't remove the grommet doesn't allow the fluid to pass back up to the master cylinder. So as they're depressing the clutch and trying to bleed the system, it allows the fluid to go in but not come back out. So we've seen quite a number of failures in that regard.